Okay, so we talked about water being a polar molecule. That polarity, that negative and positive end, generated by the unequal sharing of electrons between the oxygen and the two hydrogens within that water molecule. But then I told you water has some special properties because of that polarity. And I'm finally, as the slide says, going to get to the point, and those special properties are called cohesion and adhesion. Both of which we will see in this class. So cohesion, what is cohesion? Well, you should know from Quizlet, cohesion is the attraction between molecules of the same substance. So water being attracted to water. Now, think back to a slide ago, just to the end of the last screencast. What type of bond would be formed between water molecules? Hydrogen bond, correct. To make a water molecule between the hydrogens and the oxygen of one water molecule, those are polar covalent bonds. So do not get the two confused, please. So again, cohesion, attraction between molecules of the same substance. As we see here, our classic red and white dots representing water, all hydrogen bonded to one another. This could be like a drop of water. So water molecules stick to one another because of this idea of cohesion, and we're going to see cohesion in the lab. Cohesion occurring when a drop of water falls into a larger body of water. That's how these pillars of water are formed, water molecules sticking to one another. And adhesion. Adhesion, if cohesion is the attraction between molecules of the same substance, adhesion must be attraction between molecules of a different substance, right? You're adding a different substance, adhesion. This can happen between water molecules and your skin, the molecules of your skin. That's why sometimes you'll see water droplets run down your skin. Water molecules and molecules of glass on your car's windshield when you're driving, and you see drops of rain streaking down the passenger or driver's side windows. So when water sticks to another substance besides itself, it does so because of adhesion. Now, typically, it's because this water molecule is making hydrogen bonds with whatever other molecule it's interacting with, be it glass, be it skin, be it the enamel molecules making up your shower walls, what have you. Or I'm sorry, not enamel. Enamel's on teeth. Tile. All right, now, when it comes to water, we have to talk about solutions and suspensions, because you can make some pretty cool things with water because of this polarity. And it's two factors, it's two special properties, cohesion, adhesion. We'll talk about a third in just a little bit. So, solutions and suspensions. First off, we have something called a mixture. A mixture, think of it like trail mix, all right? Trail mix, the ingredients are not physically combined with each other. They're not chemically combined with each other. They're just kind of physically mixed up around each other. That's what a mixture is. Then we have homogeneous mixtures. That's where everything is mixed evenly. And an example of that would be milk. There are multiple substances or parts to milk, but they're all mixed evenly. And anywhere I look in this milk bottle, it just looks like milk. So it's a homogeneous mixture. Then you have heterogeneous mixtures, where the parts of a mixture are mixed unevenly, and an example would be like an oil spill, right? In a large body of water, the oil and the water are not mixing evenly. The oil looks like a separate entity from the water, so it's a heterogeneous mixture. Now, a solution is the same thing as a homogeneous mixture. The parts of a solution are evenly mixed. So homogeneous mixture and solution can be like synonyms here. Typically, I like to just say solution. Homogeneous mixtures is a lot more syllables. So the two parts of a solution, I hope you already know this, are the solvent and the solute. The solute is the substance that is dissolved. Solvent is the substance that does the dissolving. And typically we call water the universal solvent because water will dissolve most things in the universe if given enough time. Because of its polarity, positive and negative ends means it can make interactions with any charged molecule or atom. So we have an example. If you place salt crystals into water, then the salt will be the solute and the water will be the solvent, and you'll be left with, you guessed it, salt water. And lastly, suspensions. We're just kind of breezing through these because this is pretty basic stuff. We might make some suspensions in the lab. A suspension, as you can see here from these suspensions I made many, many moons ago, it's just a mixture of water and something that doesn't dissolve in water, like oil, for instance. Water, although the universal solvent, does not dissolve everything, but rather separates and settles out, as you can see here, typically based on density. All right, the more dense liquid on the bottom and less dense and lesser dense still. This is referred to as settling out. All right, these are suspensions. This column, row of water is suspended above this. This column or row is suspended above this. It is a suspension. Water does not dissolve everything, but it does dissolve most things. Your blood is actually technically a suspension because your blood is water-based. There's components of your blood called plasma, which is like a clear water-like based fluid, and then you have the red blood cells within your blood that give it that red or deep, almost black appearance. The red blood cells do not dissolve in water. They settle out and therefore are suspended within the plasma portion, aka the watery substance of your blood. All right, folks. Can't have life without it, right? Well, that's exactly right. Water actually makes life on Earth possible. Okay. First and foremost, way back when life first started, a few billion years ago, the earliest records we have as discoveries are that water was the cultivator of life. Life began in water. Now, why would life begin in water? We know that you and I are dependent on water, and most living things need to ingest it, but why would life start in water? I want you to keep that question in your mind as I go through this. So we know water is cohesive. Cohesive means that water will stick or form hydrogen bonds with itself. So this means that water likes to stick together. Now, even at a wide range of temperatures, between like almost 200 degrees Fahrenheit and like 33 degrees Fahrenheit, this sticking together of water molecules makes water a liquid. So from a vast range of temperatures, water will stay a liquid. But if the temperature gets too high, we know this, right around 200, 212 degrees Fahrenheit, hydrogen bonds, the bonds between water molecules, will be broken. And the water molecules will eventually break off, or the hydrogen atoms will eventually escape into the atmosphere as a gas. Folks, ran a little over on this one. Sorry about that. See you in the next one.